Hello and welcome back to the channel. In this video, I am going to show you how to create a Hello World program for the operating system using assembler. If you would like an introduction to the operating system, then refer to the link in the description. Make sure you have installed NetWide Assembler. The link is provided in the description, and it is supported on Mac, Windows, and Linux. Before you begin programming, you will need to get an assembler library to help create the program. Go to the GitHub website, the link is provided in the description below, and navigate to the Libraries folder. For this program, we are going to want to use the lib_app library. This library contains many of the common functions you would need to write a program. Now, let's write the Hello World program. Use a text editor to create the source code. A very common text editor is Visual Code. Create a new file called helloworld.asm. The first 3 lines are needed in every program. You need to specify the originate address, the bit size, and the entry point into the program. After that, things become very flexible. The next line to add is the message that will be displayed. In this case, it will be Hello World. All strings must end with a 0, which is the same as null in C. This is how the operating system knows it has reached the end of the string. I always use this part of a program to create all the data and global variables I need. I also use this part of a program if I want to create specific templates to share and pass data. More on that in another video. Next, we need to specify the library to include into the program. This library has the print function we will use. Now you add the entry point. With assembler, all labels are case-sensitive and have a colon at the end of the word. The jump statement at the beginning of the program has to match this label. I like to use the word entry in all uppercase letters. Let's talk about the display screen for a minute. The way it works in this OS is very similar to a mainframe terminal, and not like a command prompt or command line interface. That is, this screen is not meant to scroll. The screen is meant to display everything you want anywhere on the screen. You can place text on the right side, left side, top, and bottom. You can make it scroll if you really want to, but for the most part, all information should be displayed somewhere on the screen. Now, let's get back to the program. The next line is to clear the screen so that we have a blank canvas to work with. At this point, we are ready to do the actual print to screen. In assembler, you will pass parameters using registers. This is done throughout the OS. If you look at the lib_app file, you will find a number of print routines. I am going to choose a common one you will use. This routine will need parameters for a row, column, and point to a string message. The AL register is the row, AH register is the column, and RSI register is the pointer to the string message. Next, we call the routine. The function name is print_CLI_XY. The very last statement in a program must call the exit routine. If you leave this out, the program will fail with a memory violation error. This is because the CPU will continue to think there is actual code to execute. A CPU only knows what it is told to do. The program is now finished. It can be found on the GitHub site in the Source Examples folder. Ready to assemble the code, but before you do, make sure the lib_app file is in the same directory as the source code file. Now, in a terminal, go to the directory where the source code and lib_app files are. Type in the command nasm hello_world.asm -fbin -l hello_world.lst -o hello_world.app. The -l parameter is to create an assembled program listing. This parameter is optional but helps when you are debugging a program. The -o is the actual binary file that will be created. You must use the app extension when you create programs for the operating system. In the next video, I will show you how to upload the binary file to the operating system and run the program.